Hello, everybody. Now I'm going to show you how to find the end behavior for rational functions. All right, before we begin, make sure you have the notes that I gave you in class. I only gave a little snippet right here in this video. All right, before we begin to find the end behavior, first thing I want you to do is determine whether you have a horizontal asymptote or not. And if you don't, that means you have a slant. So you will either have a positive slant or a negative slant. And in this table, I told you exactly what the end behavior would be given the three cases. All right, looking at the first example. The highest degree in the numerator is a 1, and the highest degree in the denominator is a 1. Since they're equal, my horizontal asymptote will be y equals -2, because I take the leading coefficients and simplify. All right, let's look at the second one. The highest degree in the numerator is 2, and the highest degree in the denominator is a 1. So, since the degree is greater in the numerator, there's no horizontal because you have a slant. Now, I have to figure out, do I have a positive slant or a negative slant? So, looking at the leading coefficients in the numerator and denominator, you can notice that I have a negative sign. So, therefore, I have a negative slant. And I'm just going to make a note right here. All right, in the last example, the highest degree in the numerator is a 1. And the highest degree in the denominator is a 2. So, since the highest degree in the denominator is greater, my horizontal asymptote is y equals 0. All right, so now that I know what my horizontal asymptotes are, or if I have a slant, I can write out my end behavior. For the first example, it will be as x approaches negative infinity, and by the way, I'm looking right here. Y approaches my horizontal asymptote, which in this case is -2. And as x approaches positive infinity, my y will approach my horizontal asymptote. All right, in the second example, since I have a negative slant, this is going to be my end behavior. So as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches negative infinity. In the last example, I'm going to go right back here because I have a horizontal asymptote. As x approaches negative infinity, my y approaches my horizontal asymptote, which is 0. And as x approaches positive infinity, my y approaches my horizontal asymptote. And that's it.